Aloha and welcome to more Similarity, Right Triangles and Trigonometry. This section we are looking at Triangle Similarity, SSS and SAS. SSS, side, side, side. SAS, side, angle, side. There's our Similarity, Right Triangles, and Trig. Okay, where should we start here? This is similar to Triangle Congruence. We add one significant thing. Proportional sides. Okay, that gets added in there. Instead of the sides being congruent, now they need to be proportional. What do we got next over here? These are some of our definitions. I didn't like the definitions in here that much. I didn't really finish this off either too. Their definition in slide 2 for instruction, I didn't like that. Very complicated, very technical. They mention a transformation, not a rigid motion. Remember, it changes sides. Scale factor, again, very technical definition in there. They didn't show it well. Remember, scale factor n equals your image over your pre-image. Right there. I forgot to get something down for similar triangles. Let's just get that. Whoops, I need something a little thinner than that. Corresponding angles are congruent. Corresponding sides in proportion. They get into some more technical definitions of stuff in here I don't like as much. Transformation, that's our rotation, reflection, translation, and dilation. Some other things to remember here. We're here in the pinkish, purplish pink color. Similarity statement. ABC is similar. The little teal means similar right there. Okay, to triangle DEF. Triangle ABC is similar to DEF. Notice AB corresponds to DE. And I'm just getting this from the thing up here. A goes to D. That's where I went. A corresponds to D. B went to E. So I mapped the same thing down here. And that's what I did on all of these. CA, last first, goes to FD, last first. I'll let you get this last one here. What does segment CB go to? Again, notice where those letters are. Respect the order. That's what I mean. I get it from the similarity statement. Here's that SSS, SAS stuff I mentioned earlier. Side, 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 angle, side. Where's my cursor? It's not what I wanted. There it is. Let's erase that. Okay. If I don't mention a slide, it doesn't mean it's not an important slide. It just means I didn't need to mention anything on it. I thought slide 2 was overly technical in its definitions, and they're trying to explain it. A diagram would have helped. Not overly crucial when they're talking about the stuff with the origin and the center of dilation. That's not something that is always taught in the instruction of this section. Slide 3. What is the missing pair of corresponding sides? That's similar to what I had you doing up here. And looking for that, except you're getting the last two pairs. This CB going to what there. You're also getting that on that one. Slide 4. They don't discuss this much here, this green comment, but whenever I do proportions, I plan it out. Order's very important. So I'm just thinking, okay, I'm going left to right. Because if I change, if I don't go left to right, left to right, left to right, it's going to mess up your results. You know, left to right, top to bottom, big to small, small to big. You know, like green triangle to purple triangle, whatever it does. And also notice I got the corresponding here. And that's what I'm showing with this stuff down here. Notice I matched up the small numbers. This is right off slide 4. 4 and 6. 4, 6, and 8, those numbers in the numerator from the left triangle. 4 is the small, 6 is the medium, 8 is the large. For the right triangle, 6, 9, and 12, same thing, small, medium, and large. So I'm matching those up. Those all simplify. They all show that those are all equal to 2/3. That's what gives us our SSS. One pair of sides in proportion, a second pair of sides in proportion, a third pair of sides in proportion. Okay. Stay consistent again. That's just the left to right, small, medium, large stuff. This is just a separate statement. Congruent is also similar. Congruent triangles are similar. Their scale factor is just 1. Slide 6, note. So I'm over here. SAS similarity. Again, notice we got this similarity marking in there. And I forgot to mention up there, that's what that means, similarity. That tells us the difference between SSS, which is for congruent. This tells us similarity. You really should state that. They don't show it in the videos. SAS, A is your included angle. They do mention that. And again, the S's, the sides are in proportion. Slide 7, I need to show you something. Okay, I'm going to slide this over. We're going to see some work for slide 7. This is the white section here. I'm going to pull this up. I'm going to go over a little bit here. So, ooh, you know what? I can't draw on this. I wish I could. I did it later for a diagram. But they're showing here, here's angle ABC. That's this angle right there. But notice when they say angle DBE, that's the exact same angle. Those are going to be congruent. They're the same angle. They are congruent. Okay? Yeah, I can't draw on there. And we check that, and that's by the reflexive property. Any angle is congruent to itself. And then they want you to check these sides. So they're going, notice they say AB, that's this side right there, and CB, that's this side right here, must be proportional to DB and EB, these smaller sides here. And this isn't looking good to me because these aren't parallel, so this isn't looking like a dilation to me. There could be some other ways to get this congruent. That's another problem. We check that, that's okay. Find and simplify this ratio. AB to DB. So that's AB is this whole one over here to DB. Now notice I have that over here. If I want to get AB, that's 10.4 plus the 5.2. Make sure you add those together. And I'm going to hide this away now. And you do that like that. You get 15.6 divided by 5.2, it comes out to 3. Now, I should have been showing there. Add it up, 15.6. Calculator divide by 3. I can see that without the calculator too, but you can use your calculator. Now, I do have a note for in your calculator over here. Notice that these two things don't come out the same if you don't use the parentheses. The only difference is the second one has the parentheses, this doesn't. If you ignore the parentheses, it's going to do, the calculator is going to do the division first, because you do division before addition, and you're going to get the wrong answer. So this is wrong over here. You put the parentheses in. Oh, I need to add that up first, and then I divide by 5.2. So, be careful. I don't have slides 8 and 9 on here. Doesn't mean they're not important. I thought they were just well explained on there. Slide 10 uses the distance formula. I could have also used my 45, 45, 90 here on this one to get some of those sides. I could have also used SAS, which they mention at the end. They show a little work in there. It's kind of missing. I would have shown in doing that addition, you know, you can see I put the, there we are. I put the, change the minus and negative into plus a positive. I like to show the steps. -6 plus 2 is -4. -4 squared gave me 16. Now, they just reduced this over there. Some of you might be able to see that. You can simplify that fraction. You know, the calculator might do it. But you want to get fractions a lot of the times, not always decimals. They haven't been real consistent about saying when they want fractions, when they want decimals. Proportions, you're going to use fractions more often, so be aware of that. Scale factors, they use decimals more, and they used fractions some. Proportions, fractions a lot more. But I just showed over here reducing this. I'm just dividing it by 2 a bunch of times. 32 divided by 2 is 16. 128 divided by 2 is 64. I just kept on reducing that all the way down to 1/4. Square root of 1/4, that's the square root of 1/4. I know my writing's getting really small here. It's the purple one. That's square root of 1 over square root of 4, which is just 1/2, or 1/2. Slide 12, it's a tougher proof. They're not asking you to do the whole thing. You can see it in slide 13. I got my answers whited out down here. But it's kind of hard to see how they went from this step. Now you can see part of this. How'd they get the 3 in the denominator? Well, they divided by 3. How'd they get the AE in the denominator? Well, they divided by AE. So there's a couple of ways you could do that. 3AC equals 7AE. You can do the division at the same time. On this side, we can see I'm going to this. I want to leave the AC on top, so I'm going to divide by 3 on each side. This side, I want to leave the 7 in the top, so I divide by AE. I divide by AE. The 3's cancel out. The AE's cancel out. We've got AC over AE equals 7/3. That's one way to do it. Some of you may like this a little bit more. I divide by 3. I divide by 3. That leaves AC equals 7 times AE over 3. Well, this kind of looks messy, dividing AE like that. But remember your old fraction rules. You know, 3/4 divided by 5/2. Whoops, that's not divided by. We do multiply by the reciprocal, so the division turns into 3/4 times, I can't write. 3/4 divided by, not divided by, times 2/5. You can reduce. I'm running out of time here. And you can do that. So instead of dividing by it, I can multiply by 1/A/E, multiply by 1/A/E, and I get that same result. AC over AE equals 7/3, and we're done. And I'm pretty much out of time here, so I'm going to end this video. Thanks much. You have a good one. I almost forgot. Here's your answer. So the diamond, that's the division property of equality. You could see me doing the diamond. Well, I also should have mentioned, mark it. I have these sides congruent. I had these sides in proportion, these sides in proportion, side angle side. Keep forgetting stuff. Side angle side. There's your answers.